Today we are going to talk about building apps for TVs using Flutter. But first, I want to introduce myself. Jaime Blasco. I'm based in Spain. I'm a senior Flutter developer working for a startup based in UK that is called Hypervolt. I'm a Google developer expert in the technology. You're also organizer for the Flutter Spain community here, there in Spain. And I think here you have all came to see this, like to see how can we, like what are the steps to build a Flutter app that we can compile and use on TVs. And I have bad news for you to say, like it's not officially supported. It's not going to be an easy path, but I think we all love a challenge, so let's get started and see what we can do. First, all the solutions, like there is a lot of tvOS platforms. There's Android TV, Google, Fire TV, tvOS, and way more than we will explore today. And all of them have a different way we can use a Flutter app with them. All of them are very early stage, and they are not very easy path. But I think the future is bright, it's very promising, so it's better to start now, invest the time and resources to build something that we can scale in the future. So, first of all, before I start explaining anything, I really wanted to thank Sasha Denisov, that is a Flutter engineer based in Berlin that has been working with TV, like building Flutter apps on TVs for more than 2 years. Most of the content that you are going to explore in the internet, he has built it. There's a lot of sessions, a lot of documentation, and he's the one that is behind him. So I'm really thankful for him. He helped me a lot when I was building up TV apps this year, and also I think it will be very helpful for you if you ever want to start with this. And to explore which platform do you want to invest the time and resources to build an app, I think it's better to start researching a bit. There is they released this year, a global like a chart about research about explaining what was the market share of tvOS in the world. Also, we'll explain a bit how it's in US. So I think it's not a surprise for us that Samsung is leading the way with Tizen OS, but maybe it can be more surprised, like Vida OS is something I was never heard about before preparing this talk, and is from Hisense and is tvOS. It's a company based on China, and I think it's the second manufacturer there in China. So they have a lot of companies, Toshiba is one of them, and they have this operating system mostly in Asia and Europe. And then, of course, I think we're more aware of WebOS from LG, Roku TV that is based in America, Fire TV, Android TV, SmartCast that is a company based in US also, Titan OS that is a OS that is being used by Philips in Europe, Apple TV OS from Apple, and TiVoOS, that's also an American company here. I think from all this chat, what it came more as a surprise to me is that Apple TV is so low in the share market, and there is other investments that can be more valuable for us. Let's see the US market. So there, Roku TV goes first, so I think it has the major share, and then other ones, I think we're all familiar, Fire TV, Tizen, Android TV, Wear OS, SmartCast, that one mentioned before, and Apple TV OS. So I think we're going to focus more on what we can build on the US market, and then we will talk about the other solutions that we can also implement, but maybe it's not the cost the effort for us today. So we're going to focus on these platforms, and the first bad news is that Roku TV is not going to be supported by what we are going to build today. The reason is because it has a proprietary and licensed technology that is used to build their own apps, and it's very similar to HTML and JavaScript. They have SceneGraph and BrightScript, and it has the same kind of thing, like the XML of the nodes and then the scripts that you can build the DOM. But yes, I think the investment to try to create something that has an interoperability with that, it doesn't cost the effort. Like, it's not worth the effort of all the resources that it needs. So we are going to start with Android TV, that I think is the easiest one and the one that will be more familiar with us, because it's an operating system that is based on Android. It has the same foundations and is very similar to mobile. And even if it's not officially supported, we can definitely use the Flutter SDK, always aware that it's not something fully supported, there can be some problems with it, but in general, the people have tried, and personally myself, everything works kind of as expected. So we will be able to compile an Android app, and that slight changes, so it works also for RTBs. It will be able to compile in an Android app bundle or an APK, and then all the plugins that we have in the Flutter ecosystem that support Android, I think most of them are working by default. That we can use Firebase, we can use WebViews, WebRTC, share preference, like a lot of variety of the ecosystem. We always have to be cautious because at the end, most of the limitation is going to become by the hardware. Like it doesn't have, I would say most of them doesn't have a touchscreen. Some cannot have Bluetooth, other ones like only have Wi-Fi via, or other ones only just via Ethernet. So we'll have to always check all these capabilities. And if we want to run and test this app, we will be able to use the Android TV emulator using the usual tooling that we use for Android, and also in real devices that support Google TV. Fire TV, I'm going to pass it quick because it's very similar. Like, it's an Android-based system with maybe with more modifications, but still based on Android. We will be able to use the official SDK and target as an Android app, make a slight changes, build an APK, and then most of the widgets will be working out of the box. We'll also be running the Android TV emulator, and also we can test it on our Fire TVs, even plugs. Here, it gets more tricky. Right now, we were super comfortable. We were building Android apps with our plugins that we're used to it. But with Tizen, it gets a bit more complicated. Tizen is based on Linux, and they have their own way to build apps using C# and .NET. But the thing is, there's a team at Samsung that has invested more than 4 years, a lot of time, working on providing a solution to build Flutter on the Tizen OS. So they have created a fork of the Flutter ecosystem and build their technology upon them. They have always keeping updated, super fast to be honest, because right now the latest version that they have is the same as the stable version of the Flutter SDK itself. So the only thing is that we will be able to need to download their tooling and use a command line very familiar to us. Instead of using Flutter, we will be able to use Flutter Tizen. We will compile it to a new target that is a Tizen app that has a TPK. And then I think the limitation here will be we are limited by the plugins that they offer. They offer a variety of plugins, I think it's more than 40. And I would say most of the plugins that the Flutter team supports officially, they have a version that works for Tizen. They also support other plugins that they are not officially by Flutter, like something like Firebase Core, and things like that. And also they offer a lot of packets themselves that they only work for Tizen with their own capabilities, like things like hardware, their own way of doing push notifications, and even they have a package itself that is called Tizen Interoperability, Tizen Interop, that allows you to access all the native APIs using a Dart. This uses FFA generation to create all the native APIs and expose it as a Dart interface. Very similar, we will be able to use a Tizen emulator. The bad news is only limited to Intel laptops, so if you are using probably a new Mac OS, you won't be able to use a Tizen emulator. But Windows, on other stuff that is using still Intel, you will be able to try it out. Same, you can still try it with Samsung TVs, you compile the app and give it a try there. Let me get some water. For WebOS, it's a bit tricky because I think probably most of you already knew, and you get the news 2 months ago, they announced they are going to officially support Flutter as a way to build Flutter Live WebOS apps with Flutter. The thing is, it's something that's a bit early stage. They are targeting for next year. I got to see a preview. It looks very promising, but because of the reasons, I cannot say much about it. But we can say it's going to work very similar to Tizen OS. So we'll have a new tooling, very similar to the official one, that will allow you to use their own set of plugins that they support to use and build Flutter apps. We'll be able to run it on simulators and also compile it and launch it to their app stores. Everything will be compiled in native. LGA is, for now, is a Linux-based operating system that also mainly uses web apps. It also allows you to build native apps, but I think most of the apps in the App Store, in their store, is using web apps. But it allows you also having C++ and their own SDK also for C++, but I think it's not very commonly used. The thing is, with this new technology, you will be able to compile into this native app itself. But for now, we are going to limit ourselves to using the official SDK and target the app as a web app. Then we are going to use their tooling, the official tooling, to package this web app into their own format that is called IPQ, and we will be able to use most of the web plugins that are in the market right now. We have to be cautious, because if we want to transition at some point to using the new Flutter SDK that they offer, the plugins will be more limited. And I think it will be very similar to what Tizen offers, the official ones, and some that maybe are needed from the community itself and very important. Very similar, we'll be able to run and launch our WebOS emulator and also test it on our LG TV, smart TVs. I think tvOS, I was leaving it for the last because it doesn't have a lot of markets, but I think the main problem is there is not a really official support or anyone backing the development of this technology, so it's a bit behind. We have some people like Sasha that I mentioned him before, that they have been trying to create something, but it's always very experimental, and I encourage you to try it out and everything, but it might be challenging to launch an app using this technology. Still, let's explain a bit how it works. We have our operating system that is based in Darwin. It has similar foundations to iOS, but has big difference that make it very difficult to create our Flutter app targeting iOS and then compile it to tvOS. Still, there have been people like Sasa that has forked the engine, make a new version, compile it, and reuse the iOS target that is officially supported to tweak it a bit to target as a tvOS app. And it works, and most of the things are working. Then we will have a fully tvOS app, and the thing is, the plugins like iOS plugins won't be supported by this new fork. Like Android, you can use Android plugins on Android TV. For tvOS, you won't be using iOS plugins by default. Most of them you will be able to tweak it and then add its support as tvOS as a capability and will work out of the box. But some of them you will might need to make some changes. Very similar, once you have everything set up, you will be able to use the TV simulator or the real device. And then last, I mentioned these ones that maybe are less familiar, and I grouped them all together because they are very similar. They are all operating systems that are Chromium-based, so you are building web apps, and also they're a bit more private. For the other ones, you always have public information, public documentation, the tooling is private. You can develop all the app without needing much to put in contact to them. But for the three of them here, they ask you first to try to create a partnership. It's like more close. They don't want to publish so much apps, but more like quality apps. So you might need to reach them out, create a partnership with them, and they will allow you to access their tooling and everything. But basically, from what I could try and everything, you can use the official SDK, build a web apps, because for the three ecosystems, they use web apps. Plugins also again mostly work. You will have to be cautious because it's one of the versions, uses a different Chromium version, so I think the most limitation here is which of the Chromium version is using. And for example, if it's using a Chromium version that doesn't support the WASM compilation, so you might want to skip that one and just build it as a normal web app with Canvas Kit. For testing, you will have to do it with Chrome, and if you want to test, you will have to ask for private access to, even if you want to do some debug on your TV, they have to do it manually. They enable you to be a developer itself. So we're not going to focus on them. We're going to focus on the other ones. We can group it a bit on 5 groups. Like we have the Android ones, the Tizen, the WebOS, and tvOS, and the web app ones. So I'm not going to be very detailed into this, but once I share these slides, like a summary of what we cover here, which one is the official SDK, which is the target that you compile your app into, how is like the plugin support ecosystem, and then if you can try it in your emulators or not. Let's see how I have been building up this year. So imagine you want to build an app that you want to target most of the tvOS here in the market. So they have so many different capabilities, limitations, that what I did, I created a base project. There is a Flutter project that contains all the UI and business logic of our app, and it's agnostic to the platform itself. And then I created a different Flutter project for each platform. So for example, for Android TV, you will use the target Android. For Tizen, you will use the target Tizen. For WebOS, we will use Web for now. And tvOS, we will be using iOS target. So as you can see, sometimes collapse or everything, so I think it's better to have their projects separately. So then with modules, I create different modules that have different capabilities, and not all the modules work on all the different. So for example, push notifications is something that is available for Tizen and Android TV, but it's not available, like we cannot do it for WebOS. So with this, you can inject these services and modules into your apps, but only the ones that you can work with it. So let's get started. If we wanted to create an Android TV app, we mentioned that we want to use the official SDK targeting just Android. So we will create the Android project, and we have to verify two things. First is that the minimum version of the Android SDK that we support is 21. Luckily for us, the latest Flutter version also has the minimum requirement of 21, so you won't have to make any change. I don't expect you to try to port an old code base into a new Android TV app, but if you do so, please take that into consideration. For other tweaks that you need to do is to launch into the App Store. You have to modify your Android manifest and tell that it's not a requirement itself to use touchscreen. Like it's something that is required by default for an Android app. So we'll have to tell when we upload to the App Store that the touchscreen is not something required for our TV app. And then also we have to disable the category of Limbats launcher and enable the category of launcher itself. So this is just copy and paste this code, and you will have your app ready for launching on the App Store. Very similar of what we can do with an Android simulator, we will be able to create an emulator of TV, target, and create it, and run it on Visual Studio Code, on Android Studio Code, and try it out there. For Tizen, we mentioned it's a bit more complicated. I added QR code that you can see after in the slides. With the Getting Started guide, it's very detailed, very easy to follow. It explains for each platform, for Android, iOS, or Windows. Basically, you have to download the SDK and .NET framework. Then you have to clone the repository, set the path of the command itself to the path of the environmental variable, and then you can use Flutter Tizen commands like Flutter commands, and it will add a new target, like instead of Android, iOS, and all the others, you will have Tizen itself. So you will call Flutter Tizen create, platform Tizen, and it will create a project itself that focus on target Tizen. With this, you can build your app, you can add your plugins itself, and if you want to test it out or launch it, you will have to create a certificate. It's very similar to the Apple certificate for developing and distributing, and it's also in the Getting Started guide. It's something that you install with this UI is installed with the SDK itself, and then you very easy steps like you want a TV certificate, you put your name, your password, you log in your Samsung account, and then you have the certificate created. And then very easily also, you have another app when you install the SDK, that is the emulator manager. You add a new emulator, that's the TV, that is created by default. You call Flutter Tizen, you initialize the emulator, you call Flutter Tizen run, and it will run your app directly on the emulator itself. I don't have I have an ARM is a macOS, a new one, so I could not test it out. I have to test it out on Ubuntu. But if you have an old macOS, you could be developing everything with a macOS. For WebOS, we mentioned we wanted to focus now to be a web app, so we will create a web app with the official SDK. We will install the WebOS tooling with the Node Package Manager, and then we have to do some tweaks to the web folder. So when you create a new project of Flutter that targets web, it creates a web folder, and we have to do some modifications there before we want to pack it as a WebOS app itself. We are going to use the WebOS tooling to create an app that is for WebOS that's going to use as a template where we can copy some code that we need for our app. So we call rgenerate with template basic, and then a path where we want to create this app. And then in our project, in our web folder, we are going to do these modifications. First, we need to add icons there that are required to display on the LG WebOS TVs. So we need to add an icon that is 80 per 80 pixels, and then one is 130. Then we will copy from these WebOS apps that we create this folder with 2 scripts. Then we move it to our web folder with the same name. We will call it WebOS TVGS 1.2.10, and it's a wrapper that WebOS required for WebOS apps to initialize all the resources that is needed for working with WebOS native APIs. Then we'll have app info.json, that is like our pub spell YAML, where we explain the information, like this configuration of our application. We add the ID of the app, who is the vendor, the title, and then we'll have to indicate the path of the icons that we mentioned before. It's very important because if you don't put the icons, the app won't compile or won't launch. So if you are trying everything, it might be one of the errors you encounter, like, why is not my app not displaying in the emulator? Maybe it was just the icons itself. So, and lastly, we'll have to update the index XML. So we have kind of remove all the things from the head itself and add these 2 scripts, one for release, one for debugging. We can add both for debugging. I think we need to add both for debugging. And then, yes, it's just copy-paste the script that will load all the wrapper resources from the JavaScript code that we have added as the folder. And then we are always familiar with that. We have to add the line to load the Flutter resources and the Flutter application using the same script that we will use in our normal Flutter app. And then with this, we can build our Flutter app with Flutter build web, and then we can launch it in the simulator with our RS launch, and then we indicate the version that we want to use for WebOS. It's 24, they have 23, 22. We're targeting the latest one, and then we put the path of the WebOS project. No? The WebOS project is the web app that is generated by Flutter, so it's the path build-web. And with this, we'll have it already in 3 platforms. I will miss tvOS apps that I will say is a bit more complicated, and it will need an entire session, and in fact, Shasa has given a lot of sessions about it, so I think it's worth you checking it in detail. We're going to make a small summary here, but I feel like if you want to go in detail into Apple TV, you have to spend more time, and I think it's worth. You can scan all the QR codes at the end, because I have a QR code with the presentation, so that will be easier for us, I think. So to make it work, we have to download the Fort engine that he created. Then we will have to I would recommend you to download their template or TBI example that he has created, because he has all the scripts there that are needed to compile the app into tvOS. So he has, what it does is first create an iOS project, it builds the iOS project, it copies the resources of the tvOS app, and then compiles the app on tvOS. For this, we'll have to do only one change to build this project. We'll have to change the Flutter local engine path that is in the project itself, and we will have to update it with the location of the engine that we just download. And with this, we can run the script that he has in the code base, and we just need to target, if we wanted to target a debug simulator, we will use a different key, but we'll just call it there. And one thing to notice here is that in his example, he also brings support for for the, well, he also has support for something that is missing on the engine itself. That is when the TV remote for Apple is a bit different. You don't have the right, left, up, and down. It has like a trackpad, like the macOS itself, and you can have different gestures like swipe, scroll, and things like that. That they are not supported directly on the engine itself. So he has kind of created something in the engine and something in the project itself through platform channels where you can communicate these key events, and then you can also make use of the remote itself in the tvOS app. And with this, we will be able already, we have the counter app in, I think, 5 different platforms, but being able to run the app in the simulator or compile it is not enough for designing and building a Flutter app on TVs. I think one of the main considerations and one of the main difficulties here is the user interaction, no? Because people interact so different between devices, like with phones, it's with touch, with computers, with the mouse on the cursor. But here, we don't have any of that. We have no touch, and they interact with remotes. So it's kind of very difficult coming from a Flutter app that I have been focusing all my life on mobile, how to change this mentality of how you should design a Flutter app on TVs. And I think first we have to understand how users interact with TVs, right? We have 3 common interactions. We have the D-pad, that is like the up, down, right, and left, that you can change the focus between the components or widgets in your screen. And then you have a central button that acts like the single tap on your Flutter app. And then you have this return button that is in mostly all of remotes that you can navigate back into the previous page. Then, depending on the platform itself, you have different special considerations that you have to take into account. For example, LG has this magic remote that if you can point it out to the TV, it acts as a cursor, so you can use this as a cursor on the TV. And then also, this is something that when I tried, it works kind of very well by default. And then Apple TV, yes, as we mentioned before, it has this trackpad that supports different gestures. It gets a bit more complicated there. So the main thing here is like to understand how the user interaction is through focus. No, so focus, the user uses the remote itself to change focus between elements. And we have to understand a bit how focus works also in Flutter. There is an amazing documentation page where it explains everything there that you can see. If you want to see in detail, we are going to do a summary here, but I think it's very useful, even just for Flutter, if you do mobile apps for Flutter, to read it out, because it tells you a bit how the process of something that is a hardware device, a hardware key like a keyboard, touch, or remote, it creates a key event, like a hardware key event that converts itself into a focus, and that changes into different focus nodes under your widget tree. There's also a lot of complexity of how to decide where the focus goes, to the left, to the right, how to modify that, which groups of focus, like are you able to focus from this place to the one below? And all this complexity, I think, is worth to read this document about, even just for mobile apps. But let's see. Imagine we have this component that we want to add our Flutter TV app. We want to be able the user to focus it. So we can add this focus widget that what it does is creates a focus node on the focus tree that you are able to select through a user interaction. So imagine the user clicks the right button and it focuses to this one. We can use this focus node to access the properties of to understand what is happening with this focus. We can check if it has focus or not. We can even request the focus itself programmatically. We can change to focus in one of the directions, like from this component, focus to the right, focus to the top, focus to the left, or we can even call it on focus. In the focus widget, we can also call autofocus and set it to true. So we can only do it in once, otherwise there will be it will collide a bit. But if you only autofocus one element, once the user opens the app, it will focus that element by default. But now that as developers we can understand which element is focused by the user, we have also to showcase the user that his element is focused itself, right? So from all these elements, we have to tell the user, this one is the element that you are focused, and then when you tap, you will go to a page that is related to that card itself. For that, we have our focus widget. So inside this focus widget, all the widgets that we build inside, we will be able to access a focus node calling focus.ofContext. And every time this focus changes, this widget will be revealed with new data related to the focus. So imagine we have the focus, and then we have a my card widget that we have a build method where we call focus.ofContext has focus. So every time each card changes the focus, we'll rebuild this method, and we could animate using animated size, animated container, or even twin builder. We'll be able to animate these animations and indicate the user, for example, that the center one is animated, right? So we can scale one element to tell it's focus. Maybe we can add some elevation with shadows, and also maybe add some opacity for the ones that we don't display. Very similar for that, we can add nested focus. So we have 2 rows of elements that are scrollable. So we have one element that has a focus widget, another element that has another focus widget, and then every one of them inside has also a focus widget itself. So if this element that is the darkest one is focused itself, we'll know that his focus node is focused, but also his parent focus widget with the focus node will also has focus to true. So for example, we can change the background of the whole road itself. To know which widget is really focused itself, like the one in the dark, we also have this parameter that has primary focus that tells you from all the widget tree the lowest boundary that has the focus itself. And then there are all his parents will have also focus, but it tells you which one is the lowest in the widget tree itself. And with this, I think we are ready to build an app. We know how the user interacts, we know how to build apps. I think it's important that even if it's something that is very challenging and very difficult, with trying this, we can build Flutter apps for targeting Android apps, targeting Tizen apps, also targeting as a web apps and tvOS apps, and we will have more than half of the support for more than half of the smart TVs in the world. So I think it's something that is very early stage, but it's very permissible, and I think we should start investing on it and experiment with it. So thank you so much. Here are the slides, and if you have any questions, you can ask me here or later during the day. Thank you.